Okay, a commuter must pass through 5 traffic lights on her way to work each day and has to stop at each one that is red. Desiring to know what the average number of lights she will have to stop at on any given day, she collects data on 200 days she drives to work. Turns out that 10 of the 200 days, she had to stop 0 times, so she was able to go through all of the lights without stopping. 50 days out of the 200, she stopped 1 time. 70 days out of the 200, she stopped twice. 30 days, she stopped 3 times. 30 days, she stopped 4 times. And 10 days, she stopped all 5 times. Can you help her figure out what the average number of times she stops per day? Also, go ahead and find the standard deviation. Okay, the average number of red light stops that's made per day, we're going to go ahead and set up the random variable to measure that. We're going to let x equal the number of red light stops on any given day. Now, x is a discrete random variable. Because there are 5 lights, if we let x be the number of red lights stopped on any given day, there's only a finite number of possibilities for x. 0, 1, 2, 3, 4, and 5. Now, to set up a probability distribution, I need to show how the probabilities are distributed for these values of x. And I'm going to look at the data that she's collected. It turns out that on 10 days out of the 200, she stopped 0 times. So 10 divided by 200 is 0.05. So 5% of the time she stopped 0 times. In other words, what's the chance that she is going to get through all 5 red lights on any given day? It's a 5% chance of that happening based on her collected data. Turns out that 50 out of the 200 days she stopped 1 time. So 50 divided by 200 is 0.25. So 25% of the time she stopped 1 time. And I'm going to let the probability that on any given day she stops 1 time be 25%. There were 70 days out of the 200 that she stopped twice. 70 divided by 200, that's 0.35. So 35% probability that on any given day she would have to stop twice. Okay, 30 days she stopped 3 times, and 30 days she stopped 4 times. So 30 divided by 200 is 0.15. So the probability that she would have to stop 3 times or 4 times are both 15%. And 10 days she stopped all 5 times. So that again is 5% chance that on any given day she is going to have to stop at every light. Now, to calculate the average, I'm going to go ahead and use the expected value formula. In other words, what's the expected number of times she's going to have to stop on any given day? Well, that's the average number of times that she would have to stop. That is the expected value. The formula would be mu for the average, which is also the expected value of the random variable, and we write e of x for that, and that's the sum of x times f of x. Now, you might think that to find the average, I would just take the values of x 0, 1, 2, 3, 4, 5 and divide by 6 and get 3. But you'll notice that each one of these values of x has a different weight to it. In other words, it's more likely that she will stop twice than she will stop one time or none. It is less likely that she will stop 5 times as opposed to 4 times. So not all of these values of x are equally weighted. So I can't just take 0 plus 1 plus 2 plus 3 plus 4 plus 5 and divide by 6. That's not going to give me the average. I have to consider the probability of each of these values of x when I calculate the average. And that's what this formula is doing. So to calculate the average, looking at the formula, I'm going to add these products, x times f of x. So I've got to find what they are. And I'm going to go ahead and create another column there. 0 times 0.05 is 0. 1 times 0.25 is 0.25. So again, I'm multiplying the values in the first and second column together. 2 times 0.35 is 0.7. 3 times 0.15 is 0.45. 4 times 0.15 is 0.60. And 5 times 0.05 is 0.29. So to add all of those together, add them all up, I end up with 2.25. So that is going to be the answer to the first question. What is the average number of lights that she will have to stop at on any given day? Is 2.25. In other words, if I just look at every day and how many lights she stopped and add them all up and divide by the total, that value would be 2.25, the average number of stops per day. Now, to get the standard deviation, I'm going to have to calculate the variance, the sigma squared, and then take the square root of that to get the standard deviation. So my formula for variance, the variance of the random variable x, which is, I'm going to use sigma, the population variance, and that is the sum of the square differences, the difference between the random variable's values and the average that I just calculated, squared, and each of those times the probabilities. And that's going to give me the variance. So to go ahead and get the values I need to add together for that summation formula, I'm going to create another column, x minus mu, where mu is 2.25. And let's see, 2.25. I'll have 0 subtract 2.25, which would be a negative 2.25 for the first row. 1 subtract 2.25, which would be a negative 1.25. 2 subtract 2.25, which is a negative 0.25. 3 subtract 2.25 is 0.75. 4 subtract 2.25, 1.75. And 5 subtract 2.25 is 2.75. Okay, next thing I need to do is to square these values. And I get 5.0625 when I square negative 2.25, so that's going to be a positive 5.0625. When I square a negative 1.25, I'm going to get 1.5625. Squaring a negative 0.25, I get 0.0625. Squaring 0.75, I get 0.5625. Squaring 1.75, I get 3.0625. And then squaring the 2.75, I get 7.5625. Okay, the last thing I need to do is to take those values and multiply by the probabilities. And that column is going to be added up to give me my variance. Okay, let's start the calculations here. I'm going to take 5.0625 and multiply it by f of x. That'd be 0.05. And that will give me 0.2531. Then I'm going to take 1.5625 and multiply it by the f of x value, 0.25. And that will give me 0.3906. 0.0625 times 0.35 would give me 0.0219, and I'll continue in that fashion all the way down, getting 0.0844, 0.4594, and 0.3781. Okay, so I need to add those all together now, and I will get 1.5875. So that is my variance. So my standard deviation would just be taking the square root of that. So the square root of 1.5875 is equal to 1, I'm going to round a little bit, 1.26. And that is going to be my standard deviation of the random variable x.